Usually when we talk about getting a diagnosis, like a medical diagnosis, there's this underlying expectation of precision, right?
Absolutely. Yeah.
It feels like engineering.
Yeah.
Like you break your arm, they do an x-ray, and shows that jagged white line on the bone, and the doctor just points at the screen and says, well, there it is.
Right. It's binary.
Exactly. It's clean. It's either broken or it's not. And I think, we bring that exact same mindset into our work, especially for you listening right now. If you're a manager or an executive, you want that deep practical knowledge without all the noise.
Yeah.
You want to find the broken part and just fix it.
Yeah, because our brains are deeply wired to crave that exact kind of clarity. I mean, we are basically hunters of the single broken part.
No.
We want to find the defective widget, swap it out, and just, move on with our lives.
But then you step out of the clinic and into the world of actual, real complex systems.
Right. The real world.
Yeah. Whether you're looking at a massive global supply chain stretching across 3 continents, or a huge government bureaucracy, or honestly, even just the daily operations of a mid-sized software company.
Yeah.
Suddenly that x-ray machine is just completely useless.
Yeah.
You're looking at this diagnostic landscape where cause and effect are totally separated, like separated by time, by geography, by layers of management. You fix a procurement issue in Dallas, and 6 months later, a manufacturing line in Munich just grinds to a halt.
It's the absolute definition of diagnostic muddy waters.
Right.
The interconnectedness of modern systems means that local symptoms almost never point to local causes. And that terrifying reality is exactly why Dr. Eli Goldratt, right before he passed away in 2011, left his longtime protege, Dr. Alan Barnard, with this incredibly daunting challenge.
Yeah, and this is what we're going to unpack today.
Exactly. Goldratt told him, and this is a quote, "Do not dare stand in my shadow. Stand on my shoulders."
I really love that framing because Dr. Goldratt, he isn't just a footnote in business history.
Not at all.
He's the physicist turned guru who basically rewired modern management in the 1980s with the theory of constraints. Like his business novel, The Goal, is essentially a sacred text in operations.
Yeah, it really is. It gave us the definitive framework for finding bottlenecks.
Right. But his challenge to Dr. Barnard wasn't to just preserve that theory in amber. It was a mandate to evolve it, to basically upgrade the operating system of the theory of constraints so it could actually survive the sheer overwhelming complexity of the world we live in today. And that's our mission for this deep dive. We're going through Dr. Barnard's white paper, Beyond the Weakest Link, to see exactly how he did that.
And it's so important because Goldratt harbored this profound fear near the end of his life. He was terrified that his life's work would become dogma.
Oh, interesting. Like it would just become a rigid set of rules.
Exactly. He recognized that the moment an organization stops treating a theory as a living, breathing thinking process and starts treating it as just, a checklist, the theory becomes completely useless.
Right.
He literally warned that finding the quote-unquote final answer is just proof that you've stopped thinking.
Wow.
So Dr. Barnard taking up this mantle, publishing this white paper, it's the ultimate tribute. He isn't tearing down the classic theory. He is rigorously expanding it to handle the chaos we deal with today.
And to really grasp the magnitude of Barnard's 5 big innovations here, I think we have to look at the baseline first. The original problem Goldratt solved. Because prior to the 1980s, if you wanted to improve a factory, the prevailing logic was just entirely reductionist.
Oh, yeah, very much so.
You broke the system into individual pieces, and you tried to make every single piece run at 100% maximum efficiency, which, sounds perfectly logical on paper. If every gear on the watch is spinning as fast as possible, the watch must be running perfectly.
It sounds logical, but it is mathematically disastrous.
Right.
That approach is known as the local optima problem. In any interdependent system, improving a local part in isolation often actively degrades the performance of the whole system.
It's like deciding to optimize your car by installing a massive 1,000-horsepower racing engine, but you leave the stock transmission and bald tires on it.
Exactly.
You haven't made a faster car. You've just built a machine that's designed to violently tear itself apart the second you hit the gas.
That is a brutally accurate way to describe most corporate efficiency initiatives, honestly. Yeah.
Okay.
Consider a purchasing department. The VP of purchasing gets a massive year-end bonus for driving down the unit cost of raw materials. That's their local metric, right?
Right.
So they switch to a cheaper supplier. But those cheaper components have a slightly higher variance in size, which ends up jamming the calibration machines on the factory floor.
Oh, no.
So the machines go down, maintenance costs skyrocket, and the final assembly line is starved for parts. The purchasing dashboard flashes green, the VP gets a huge check, but the factory is bleeding cash and missing customer deadlines.
So everyone is hitting their individual KPIs, but
Mhm.
the ship is actively sinking. And telling a CEO to, just optimize the whole system isn't helpful at all. It's way too big. So Goldratt brought in that legendary, breathtakingly simple analogy, the chain.
Right, because the physical properties of a chain bypass all that corporate noise. If you are pulling a heavy load, the strength of that chain is dictated by one element,
The weakest link.
the weakest link. You can spend millions of dollars polishing and reinforcing the 99 strong links.
Right.
But if you don't strengthen that one specific weak link, the chain cannot hold a single ounce more. The system's maximum performance is entirely limited by its constraint.
When you view a business through that lens, local optimization doesn't just look inefficient. It looks totally delusional.
It does.
You've got managers out there meticulously buffing the strongest links while the chain is actively snapping in half. And for 30 years, finding that weak link, managing the flow rate constraint, it revolutionized global industries.
But then Dr. Barnard spent decades implementing this across 6 continents. He worked with Australian mining conglomerates, Silicon Valley tech giants, government agencies.
He saw it all.
He really did. And despite the elegance of Goldratt's theory, Barnard started hitting a wall. He observed situations where finding the weakest link and maximizing its throughput wasn't actually solving the organization's problem.
Wait, really?
Yeah. In fact, sometimes it was making things worse.
Okay, which pulls us directly into the first major evolution in this paper, what Dr. Barnard calls step 0, the missing foundation. And I love the anecdote he shares here about a high-tech company in Silicon Valley because it perfectly illustrates how you can flawlessly execute the original theory and still end up with a furious customer base.
It's a very sobering case study. So Barnard and this tech company executed a textbook theory of constraints implementation. They analyzed their manufacturing process and located the undisputed weakest link.
Okay, what was it?
It was their final assembly and testing department. They called it FAT. Work was piling up in front of it. It was the classic bottleneck choking the factory's output.
So they did what you're supposed to do, right? They
Okay.
exploited it.
Exactly. They stopped overproducing upstream. They made sure the FAT department never starved for materials and was never blocked from offloading finished goods. They literally subordinated the entire factory's rhythm to the pace of this one assembly line.
Right, and the physical results were staggering from what I read.
Oh, massive. They achieved a 47% increase in production volume.
That's insane.
A 47% jump in throughput from an existing factory floor. That is the kind of metric that normally gets a plant manager featured in industry magazines. They were finally meeting their monthly aggregate demand.
Okay, let's unpack this, though, because a 47% increase sounds like a massive win. Why was the senior VP of manufacturing still getting complaints from customers?
Yeah.
Like pulling Dr. Barnard aside and saying they have a massive problem.
Because despite pushing out 47% more product, the customers were screaming at them. The supply lead times, meaning the actual calendar days a customer waits between placing an order and receiving the hardware, hadn't improved by a single day. And the delivery reliability, meaning hitting the promised delivery date with the correct specs, had actually deteriorated.
Wait, I need to visualize the physics of this.
Yeah.
If I'm pushing 47% more volume through the factory, how am I getting worse at delivering on time? Are they just piling up finished goods that don't match the immediate specific orders coming in? Like, is the system just choked with the wrong kind of inventory?
That is the exact mechanism of failure.
Really?
Yeah. By hyper-focusing on getting the factory to do more, they absolutely strengthened the weakest link in the chain. The chain could pull more weight, but they didn't make the chain shorter. They didn't make it more reliable.
Oh, I see.
This was Barnard's massive epiphany. Once they achieved the volume to meet market demand, the fundamental goal of the system had changed.
And the original theory kind of assumes the goal is static, right?
Yeah.
And it assumes the goal is always just make more money by pushing more throughput. But a constraint isn't like an absolute physical law. It's relative. A
Yeah.
resource is only a constraint relative to what the system is currently trying to achieve.
That is the absolute crux of step 0. If you don't define the specific immediate goal of the system, identifying a constraint is just dangerous guesswork. It's misdirection masquerading as optimization.
Because if your goal is to push more volume, that effort department is absolutely your constraint.
Right.
But if your goal is to deliver faster to the end user, the effort department might not be the problem at all. The bottleneck for speed might be, the order processing software in the front office or the logistics vendor handling the shipping.
Exactly. And to prevent this, the white paper lays out a very rigid, specific hierarchy of sub-goals. 5 distinct targets. And the sequence is not a menu you get to pick from based on your mood.
Right. You can't just skip around.
No, it's a strict operational order of operations. More, faster, better, cheaper, simpler.
Okay, let's walk through the sequence because this is so important for the listener.
The sequence is everything. Goal number 1 is more. This means increasing capacity, output, or throughput. The mandate here is that you must focus your entire organization on doing more until your supply capacity meets or exceeds your customer demand.
Which is basic survival, right? Like if 100 people want to buy your software and your servers can only handle 50, your only existential priority is figuring out how to handle 100. Nothing else matters yet.
Correct. But the moment you can handle 100, the moment demand is met, continuing to obsess over more is a complete waste of capital. You have to pivot. You move to the next goal in the sequence, faster.
Reducing lead time.
Yes. You focus on faster until you comfortably meet your customer's tolerance for waiting.
Okay.
If your market expects delivery in 3 days and you are consistently delivering in 3 days, you stop spending millions trying to deliver in 3 hours.
Because the customer won't pay a premium for speed they don't value.
Exactly. Once you hit that threshold, you move to the third goal.
Which is better.
Better. Improving quality, reliability, effectiveness, precision. You focus here until you consistently meet or exceed the customer's quality expectations.
And only after an organization has secured more, faster, and better, only then do they earn the right to look at number 4, which is cheaper.
Yes, cheaper, reducing cost, eliminating waste, lowering resource consumption. But the critical caveat here, and this is the rule that most modern corporations routinely violate, is that you only pursue cheaper as long as it does not negatively impact more, faster, or better.
Man, this feels like the trap that destroys 90% of legacy companies.
Oh, easily.
Wall Street demands better margins, a new CEO comes in, and the immediate reflexive mandate is just cut costs. So they slash departmental budgets across the board, they lay off tenured experienced staff and replace them with junior hires. They downgrade the quality of their raw materials, and they successfully hit the cheaper metric on the quarterly report.
But look at the systemic cascade that follows.
Right.
Because they fired their most experienced engineers, their development cycle doubles, so they are no longer faster.
Ouch.
Because they bought cheaper materials, product defect rates spike, so they are no longer better.
Yeah.
And because of the rework and delays, their overall capacity drops, so they can't even do more. By ignoring the sequence of the 5 goals, they achieved a local financial metric, but systematically dismantled their own global competitiveness.
It's the corporate equivalent of starving yourself to lose weight and then acting surprised when you don't have the muscle mass to run a marathon.
That's a great way to put it.
You amputated a limb to layer the number on the scale. And then there's the 5th goal, right? Assuming you somehow survive cheaper.
The 5th is simpler. Reducing dependencies, cutting bureaucratic red tape, eliminating unnecessary approvals. And just like cheaper, you only simplify if it doesn't degrade the first 3 goals.
So the takeaway for the listener right now, whether you run a massive logistics hub or a 5-person marketing agency, is to really audit your current objective. What is your team actually agonizing over this quarter? Are you trying to make your team faster when your actual problem is you need to be better? The sequence matters.
It dictates the entire strategy, and defining that goal fundamentally changes the physical nature of the constraint you need to look for, which is the perfect bridge into Dr. Barnard's second major innovation.
Right. Getting beyond the weakest link.
Because once you admit that the goal isn't always more, you suddenly realize that Goldratt's famous weakest link metaphor has a massive conceptual blind spot.
This is where the framework gets incredibly three-dimensional. Because Goldratt taught us that a chain is only as strong as its weakest link. Find the weak link, fix it. But Barnard asks this brilliantly disruptive question. Is strength the only performance dimension of a chain that actually matters?
And it's a question that completely reframes how we look at operations.
Let me test an analogy on you here.
Go for it.
If I'm managing a Formula One race car, and my entire worldview is based on upgrading the engine to squeeze out more horsepower, that's strength.
Right.
I want more pulling power, more speed on the straightaways. But if I'm obsessing over the engine block while ignoring the fact that the aerodynamic wing is snapped in half and the steering wheel is totally detached, well, strength is completely irrelevant. A 1,000 horsepower engine in a car that can't turn is just an incredibly expensive way to crash into a wall.
That is a perfect translation of the concept.
Yeah.
A physical chain has strength, absolutely. But if you hold a heavy iron chain in your hands, you realize it has other physical properties too.
Right.
It has length. It has the physical quality of the metallurgy. It has weight. It has complexity, like how tangled or knotted the links are.
And these 5 physical dimensions of the chain map flawlessly onto the 5 sub-goals we just established.
They map one to one. It's beautiful. The original theory of constraints was perfectly engineered for the goal of more. If you want more, you must evaluate the dimension of strength, and your constraint is strictly the weakest link.
The flow rate constraint.
Exactly. But if our system is mature and we are already meeting demand, our goal shifts to faster.
So what happens to the chain then?
If the goal is faster, staring at the weakest link is completely useless. You have to evaluate the dimension of length, and your constraint becomes the longest link.
Okay, so what is the specific step in your workflow that consumes the most calendar time? That's the flow time constraint.
Precisely. And if the market is demanding better,
Then you shift to the dimension of quality, I assume.
yes, for better, you shift to quality. Your target is the faultiest link. Where is the highest concentration of errors or defects originating? That is your flow quality constraint.
And then cheaper maps to weight.
Yes. For cheaper, you seek out the heaviest link, the single step or department that consumes the most financial or physical resources, the flow cost constraint.
And finally, simpler maps to complexity. You look for the unnecessary links, like redundant approval processes or legacy software nodes, the flow complexity constraint.
What makes this multidimensional framework so powerful is that these dimensions do not behave by the same mathematical rules. They are governed by entirely different physics.
Break that down for me. How does the math actually change?
Well, take strength. The math of strength is absolute and binary. It is dictated 100% by the single weakest link. Imagine a chain with 100 links. 99 of those links are forged from titanium and can hold 10,000 pounds.
Okay.
One link is made of cheap plastic and holds 10 pounds.
So the whole chain only holds 10 pounds.
Exactly. Upgrading the titanium links to carbon fiber does absolutely zero for the system. This nonlinear bottleneck physics is why Goldratt's original insight was such a paradigm shift.
Right. Any improvement made anywhere besides the bottleneck is just a total illusion, a waste of money.
Exactly. But now, apply that logic to length. If your goal is faster, the length of a chain isn't dictated by one single link. It is the cumulative sum of all the links.
Oh, that's a huge difference.
Right. Now, the longest link contributes the lion's share of the delay, so you target it first. But mathematically, shortening any link makes the overall chain a tiny bit shorter.
So it's cumulative. Every hour saved anywhere is an hour saved for the whole system.
Yes. And here is where the physics interlock. Shorter chains are inherently stronger and lighter. By compressing the flow time, you naturally reduce the holding costs of inventory, and you frequently expose hidden capacity.
Wow. What about quality? The faultiest link.
Quality is driven by the compounding probability of failure. A defect can technically occur at any node and ruin the final product, but statistically, the faultiest link generates the vast majority of the variance.
So it's about probability.
Yes. By isolating and stabilizing that specific process, fixing the faultiest link, you drastically alter the probability curve of the entire system.
And weight for cheaper.
Weight behaves like length. It's cumulative. The total cost is the sum of all activities. But you hunt for the heaviest link, the single most expensive node, and you engineer a way to reduce its weight without accidentally weakening the chain's strength or degrading its quality.
Which again is why doing cheaper out of sequence is so fatal. If you hollow out the heaviest link without understanding its role in strength or quality, the chain snaps.
Exactly.
And the final dimension, complexity.
Complexity is the silent killer because it doesn't grow linearly. It grows exponentially. Metcalfe's law essentially states that as you add nodes to a network, the number of potential connections, and therefore potential points of friction, explodes.
Right. More moving parts.
Every redundant approval layer you add multiplies the chances of a communication breakdown. But the inverse is also true. When you aggressively prune unnecessary links, you trigger a cascading positive effect across all other dimensions. A simpler system is mathematically destined to be faster, cheaper, more reliable, and stronger.
That's incredible. Now, to ground this in reality, the white paper outlines two wildly different industries that fundamentally misdiagnose their constraints before applying this multidimensional lens: book publishing and steel production.
They are magnificent examples of diagnostic failure.
Let's look at book publishing first.
Okay, so like many legacy media industries, they were staring down shrinking profit margins. So leadership looked at the board and decided their existential goal was cheaper. They believed they had a weight problem. They started hunting for the heaviest links, negotiating brutally with printers to cut cents off paper costs, freezing editor salaries, slashing marketing budgets.
A total panic-driven, localized optimization. They are just squeezing pennies out of every single link.
Right. But when Barnard's framework was applied, they realized their primary illness wasn't actually cost. Their actual constraint was flow time. The goal needed to be faster.
Interesting.
The traditional pipeline, from manuscript acquisition to editorial, typesetting, printing, and finally sitting on a bookstore shelf, was taking anywhere from 9 to 18 months.
That is an immense amount of capital tied up in inventory that just isn't moving.
Precisely. By shifting their gaze away from the heaviest link and focusing entirely on the longest link, they revolutionized their cycle time. They streamlined the editorial handoffs. Getting books to market in 3 months instead of 12 drastically improved their cash flow, allowed them to capitalize on rapid market trends, and ultimately it solved their margin problem.
So they fixed the cost issue by solving the speed issue.
Yes. They thought they needed a lighter chain, but they actually needed a shorter one.
What about the steel mill? Because that's a totally different environment.
Steel manufacturing is the ultimate heavy industry. If you bring a traditional operations consultant into a steel plant, the sheer physical scale biases them. They look at the massive blast furnace or the continuous caster, and they immediately conclude the goal is more.
Because it's a commodities game.
Yeah.
The assumption is always volume. Just push more metal.
Exactly. They look for the flow rate constraint, the weakest link, and try to maximize its tonnage. But a multidimensional analysis revealed that true capacity wasn't their constraint at all. Their illness was reliability.
The faultiest link.
The faultiest link. They had severe quality variance in their early stages of melting and chemical composition. Because the steel was slightly out of spec, it created a massive cascade of chaos downstream.
So the furnace is pumping out massive tonnage, but a huge percentage of it requires rework, or it jams the rolling mills, or it has to be scrapped entirely.
Yes. The system was choking on its own defects. Their goal shouldn't have been more. It critically needed to be better.
Wow.
By shifting their operational focus to the flow quality constraint, fixing the faultiest link instead of pushing the weakest one, the transformation was radical. Once the chemical quality stabilized, the rework vanished. And because the rework vanished, their total throughput naturally skyrocketed and their operating costs plummeted.
That is just a phenomenal paradigm shift. It's like putting on a pair of glasses that lets you see the actual structural matrix of your business.
It really is.
But this leads to a very dark, very important question, which brings us to Dr. Barnard's third innovation, the measurement trap.
Oh, this is crucial.
Right, because let's say you do everything right. You define the goal perfectly. You use the dimensions to find the exact longest or faultiest link. You deploy a brilliant strategy. How do you actually prove it's working? Because if your internal corporate dashboard is feeding you bad data, you're just running faster in the wrong direction.
This is arguably the most insidious structural problem in modern management. Bad measurements will actively hunt down and destroy good strategies. Charlie Munger famously said, "Show me the incentive and I will show you the outcome."
Right.
If you measure and reward the wrong metric, intelligent, capable managers will do the wrong things brilliantly.
There's a story in the paper about Cisco Systems in 2003 that honestly, it stressed me out just reading it because I know thousands of companies are falling into this exact trap right now. Paint the picture for us. Dr. Barnard is running a workshop at Cisco.
The year is 2003. Dr. Barnard is leading a high-level theory of constraints implementation at Cisco Systems. His internal champion is a man named Tony Banta, the executive vice president of worldwide operations.
So a massive portfolio.
Huge. Barnard is conducting a training session with Cisco leadership, and he is playing a clip from The Goal, the 1980s movie adaptation of Goldratt's book.
Which is such a deeply funny image to me. Like a room full of high-powered Silicon Valley executives in 2003 watching a slightly cheesy 1980s educational business film.
It's a great visual. for sure. But there is a pivotal scene in the movie where Jonah, the physicist mentor character, looks at the plant manager and asks this piercing question: are you measuring the right thing?
Okay.
And Tony Banta, the EVP of operations, literally pauses the tape. He stops the session dead in its tracks.
Because he realizes they aren't. He has an epiphany right there in the room.
He realizes Cisco is trapped in a devastating measurement illusion. He turns to the room and states a horrifying fact. Cisco's internal productivity metrics, the dashboards every manager is looking at, are steadily going up, but the company's actual profitability is going down.
Oh, man.
The financial gap between Cisco and their competitors is rapidly closing. The dashboard is flashing a bright, comforting green while the engine is seizing up.
Let me map out the math of this trap because the paper breaks it down, and it's called the revenue over FTE trap. FTE meaning full-time equivalent, which is basically corporate speak for headcount.
Yes. Cisco, like an astonishing number of Fortune 500 companies, measured divisional productivity as revenue divided by FTEs. Now, consider the reality of a department manager, say the head of IT or HR or a subassembly plant.
Yeah.
You have zero direct control over top-line revenue.
Right. You can't force enterprise clients to buy more routers.
Exactly. The top of the fraction is fixed by the market. But my year-end bonus, my promotion, my entire performance review is based on making that specific ratio go up.
So if I can't raise revenue, I have to shrink the denominator. I have to reduce headcount.
Exactly. And what is the fastest, most celebrated way to reduce headcount without completely halting production?
Outsourcing.
Outsourcing. So Cisco's middle management aggressively outsourced manufacturing to contract vendors. And on the internal accounting ledgers, it looked like a financial masterstroke.
Okay, let's walk through the specific standard cost accounting they were looking at, because this is fascinating.
Let's do it. The internal standard cost for Cisco to build a particular unit was $1,200. An external contract manufacturer in Asia quoted them $1,000 to deliver the exact same unit.
Simple, undeniable math. 1,200 down to 1,000. That is a crisp 20% unit cost savings.
Right.
The manager gets a massive bonus, the FTE count drops, and the productivity metric skyrockets.
That was the illusion. And it is a fatal illusion caused by the way accountants allocate overhead. Let's dissect that internal $1,200 standard cost.
Okay.
It was composed of three distinct buckets: $400 in purchased parts, $400 in direct touch labor, and $400 in allocated corporate overhead.
Meaning the amortization of the factory buildings, the executive salaries in California, the global IT infrastructure.
Exactly. Parts, labor, overhead, $400 each. Now, when that manager outsourced the manufacturing to the contractor for $1,000, did Cisco's corporate overhead vanish?
No. The California headquarters is still there. The HR department still exists. The servers are still running. You haven't canceled the lease on the building.
The overhead remained entirely intact. The only costs Cisco actually shed from their ledger were the parts and the direct labor, which totaled $800.
Oh, wow.
So the actual internal variable cost to produce that unit was only $800. The manager chose to pay an outside contractor $1,000 to do a job that was actually only costing Cisco $800 out of pocket.
That is staggering. They were not saving 20%. They were paying a 25% premium. They were hemorrhaging cash on every single unit.
Yes. And because the internal factory workers were removed from the payroll, the FTE denominator shrank and the quote-unquote productivity metric went up.
The metric actively rewarded managers for destroying the company's profitability.
It did. The measurement wasn't just inaccurate, it was a weapon of self-destruction.
It makes you wonder how many massive efficiency and restructuring drives in corporate history are actually just hiding this exact mathematical error.
I shudder to think.
So Barnard and Goldratt look at this disaster, and they realize they need to define the absolute requirements of a valid metric. And they establish three non-negotiable criteria.
Three criteria that every leader must apply to their dashboards tomorrow morning. First, status. Does the metric accurately tell us if the overall system is okay or not okay? Revenue over FTE failed this completely. It claimed Cisco was thriving while they were losing margin.
Okay, what's the second?
Second, cause. Does it accurately identify why the status is changing? Revenue over FTE pointed to headcount, completely blanding them to the cash burn of outsourcing.
And third,
incentivize. Does the metric drive behavior that benefits the entire system, not just the local silo? Revenue over FTE incentivize local managers to optimize their spreadsheet by harming global profitability.
Now, Goldratt already had a high-level metric for this, right? T over OE, throughput divided by operating expense.
Yes. Throughput is defined strictly as the rate at which the system generates money through sales. Operating expense is the rate at which the system spends money to achieve that throughput. It is brilliantly ungameable. If T goes up while OE stays flat, you are objectively more productive.
But the paper notes a severe limitation with that. T over OE works perfectly for the CEO looking at the whole company, where throughput equals cold, hard cash.
But what if I am the director of human resources or quality assurance? I don't generate revenue. I don't sell anything. How do I measure my throughput?
And this is where Dr. Barnard engineered a massive breakthrough. Innovation 3. He modified Goldratt's equation to work for any department anywhere by explicitly separating out a new critical variable, quality.
Yeah.
The new equation is productivity equals TQ over OE.
TQ over OE. Let's unpack the mechanics of that fraction.
Let's do it. T is still throughput. But for an internal department, throughput isn't revenue. It is the volume of work you deliver that your intern or external customers actually need. Not just what you are capable of producing, but what they actively require. Okay, so if I'm running HR, my throughput might be, open technical positions filled.
Exactly. Now, Q is quality. This is expressed as a percentage, a decimal between 0 and 1, representing how much of that throughput actually meets the customer's strict expectations. Did that engineer you hired stay past 90 days, or were they a terrible fit who quit immediately?
Got it.
And OE is operating expense. The total holistic cost required to produce that quality throughput. Your team's salaries, your recruiting software licenses, your allocated office space.
So it's throughput multiplied by quality divided by operating expense. Productivity equals TQ over OE.
Yes. And the sheer genius of this is that if you report the inverse of this equation, OE over TQ, you generate a metric that every single employee on Earth intuitively understands.
Which is?
The cost per unit of quality throughput.
How much does it actually cost us to do one good, useful thing?
Exactly. And the hidden power of TQ over OE is how it violently enforces the sequence of the 5 sub-goals we discussed earlier. More, faster, better, cheaper, simpler.
Wait. How does a simple math equation enforce operational sequence?
Because it makes local optimization mathematically impossible to hide.
Yeah.
If a manager tries to skip straight to cheaper, if they aggressively slash their operating expense by firing their senior QA testers, their quality is going to plummet.
Right.
Or their total throughput will drop because the junior testers work half as fast. Because the top of the fraction shrinks faster than the bottom, their overall productivity score immediately tanks. The metric instantly punishes you for cutting costs in a way that damages the product.
The math itself polices the system.
Yes.
It's like an immune system against bad management. And there is no more vivid real-world application of this than the Utah government story from 2012. Tell the listener about Kristen Cox and the state of Utah.
It is a legendary case study in systems thinking. It's 2012. Kristen Cox gets tapped by the governor of Utah. He promotes her to executive director of the governor's office of management and budget.
Okay.
And he hands her a seemingly impossible mandate: deliver a 25% productivity improvement across all 24 state government agencies.
Now, if you are an agency director in a massive state bureaucracy and the new budget czar announces a 25% productivity improvement target, what do you actually hear?
You hear 25% budget cuts.
Yeah, exactly.
Panic ensues. Bureaucracies go into survival mode. Directors start hiding discretionary funds, hoarding resources, and preparing for massive layoffs. It's terrifying.
But Kristen Cox wasn't a traditional accountant. She had been rigorously trained in the theory of constraints. She had actually attended Dr. Barnard's Odyssey program.
Right, so she brings Barnard's framework in. They realized that measuring productivity by traditional government metrics, like budget spent versus budget allocated, would just trigger destructive cost cutting. They needed TQ over OE.
So what did they do?
They systematically visited each of the 24. What is your actual throughput?
What is the specific value you are supposed to be delivering to the citizens of Utah?
Exactly. Then they constructed a TQ over OE metric for every single core process. And they rolled it all up into one comprehensive statewide metric, the inverse, OE over TQ. They isolated the exact cost per quality citizen service.
And when they finally flipped the switch, when they looked at the government through this new lens, what did the data actually reveal? Because it completely shattered everyone's assumptions, right?
It was a revelation. The agency directors inherently assumed they were failing because they were starved for cash and understaffed. They thought their constraint was more resources.
Naturally.
But when they rigorously measured TQ, the actual quality throughput reaching the citizen, they uncovered a massive phenomenon known in systems thinking as failure demand.
Failure demand. We really need to unpack that.
Failure demand, a concept pioneered by John Seddon, is work created entirely by the system's own delays, errors, and inefficiencies rather than legitimate new needs from the market.
Okay, give me an example of that.
Imagine a citizen applies for a standard building permit. The internal process is convoluted and slow. After 3 weeks of silence, the anxious citizen calls the office. A government employee has to stop their work, answer the phone, look up the file in a legacy database, explain the delay, and log the interaction.
Right.
A week later, the citizen sends a follow-up email. Another employee has to read the email, draft a response, and route it.
But none of that activity is actually processing the permit.
Exactly.
It's just servicing the delay. The system is generating its own administrative friction.
Yes. The delay manufactures artificial work. Across the 24 Utah agencies, the TQ over OE analysis revealed that an astounding 60 to 70% of total staff time was being consumed by failure demand.
60 to 70%.
Yes. The constraint wasn't a lack of budget. The constraint was internal process friction that was preventing their existing capable workforce from doing actual productive work.
They were just drowning in the noise of their own inefficiency.
Yes. So instead of universally slashing budgets by 25%, Cox used TQ over OE to aggressively target and eliminate those specific delays. They made the processes faster and better. By doing so, they wiped out the failure demand.
Wow.
And when the failure demand vanished, they suddenly freed up 60% of their staff's latent capacity to process real value demand.
And the final results. The governor wanted 25% over a few years, right?
They achieved the 25% improvement target in less than 12 months.
That's incredible.
And they generated over $100 million in recurring annual savings. The agency directors, who initially viewed Cox as an executioner, became her most passionate advocates because they finally had a metric that accurately reflected their operational reality and proved their true value.
It is the ultimate proof of concept. If you can align 24 disparate government bureaucracies to become 25% more productive in a year without mass layoffs, the math is just bulletproof.
It really is.
But as we move into Innovation 4, the subordination misunderstanding. Dr. Barnard makes a fascinating observation here. Even with the perfect goal, the exact constraint, and an ungameable metric like TQ over OE, human organizations still consistently hit a brick wall.
They do. In fact, Barnard states unequivocally that after 40 years of global implementations, he knows exactly where organizations break down. They rarely fail at step 0. Finding the constraint isn't the hard part.
So where do they fail?
They fail spectacularly at step 3 of Goldratt's original process.
Step 3, which reads, subordinate everything to the above decision.
Yes, subordination. And the root cause of this failure is that almost everyone fundamentally misinterprets what that word actually means in a systems context.
How do executives usually interpret it?
They interpret it as a hierarchical operational instruction. They think subordinate means the constraint is now the boss of the factory and every other department just has to do what the constraint tells them to do. It's viewed as a simple scheduling rule.
Okay, but that misses the point.
Completely misses the deeper, intensely difficult psychological reality of change management.
What does subordinate everything really demand then?
It demands the active identification and destruction of the old rules.
The old rules.
The historical policies, the deeply ingrained cultural behaviors, the legacy performance metrics that are in direct conflict with your new strategy. Unless you ruthlessly hunt down and dismantle the old rules, the organizational immune system will attack the new process and the system will snap violently back to the status quo.
I don't get it. I mean, if I bring my manufacturing VP a math equation that mathematically guarantees we are 47% more productive, why on earth would they fight me? That defies corporate logic. Are they just being stubborn?
It's not stubbornness at all. It's rational self-preservation. You have to empathize with the middle manager. The old rules existed for a reason. They were logical and successful in the old reality. People built their entire careers on those rules. Their annual bonuses, their mortgage payments are tied to those old metrics.
Oh, wow.
The moment you declare a new constraint and try to change the flow, you aren't just changing a spreadsheet. You are triggering a massive organizational conflict. the necessity of change versus the safety of the status quo.
You aren't fighting their logic. You are fighting their survival instinct within the corporate ecosystem.
Exactly. Let's return to that Silicon Valley tech company from the beginning. They achieved the 47% increase by fully exploiting the FAT bottleneck. But to sustain that gain, they had to fundamentally change the operational rules for the rest of the factory floor.
What specific rules had to die?
Well, to keep the flow smooth and prevent inventory from choking the system, they had to drastically reduce batch sizes. But the old rule, embedded in the company culture for decades, was always maximize batch sizes to reduce setup costs.
Right.
Furthermore, they had to stop measuring OEE, overall equipment effectiveness, on all non-constraint machines. But OEE was the golden, sacred metric that plant managers had worshipped since the 1990s.
Yeah, that's huge.
They had to implement new order fulfillment strategies that totally violated the make-to-order only mandate that the entire sales team relied on for their commission structures.
So to make the whole factory succeed, you literally have to look individual managers in the eye and say, hey, that efficiency metric you spent 10 years perfecting, the one that secures your Christmas bonus, stop doing it. In fact, do the exact opposite. And trust me, that is good for the company.
And that is exactly why implementations fail. Not because the math is flawed, but because of unresolved human conflict. This is what creates profound inertia. It is the operational embodiment of Clayton Christensen's innovator's dilemma. The agonizing inability to abandon the rules that made you historically successful, even when those exact rules are currently driving you toward bankruptcy.
Dr. Barnard breaks this down into 3 root causes for why subordination fails, right? The 3 I's: ignorance, inertia, and ineptitude.
Yes, ignorance is simply a lack of awareness, not knowing the problem exists or not understanding the solution. But surprisingly, Barnard notes this is the least common cause in mature organizations. People on the floor usually know exactly what is broken.
Which brings us to the second I, inertia.
Inertia is the true killer. We know exactly what to do, but we are paralyzed. We do not act. It is the deep psychological comfort of the status quo. It's the fear of the unknown. It is the manager quietly calculating, I know the new system is better for the enterprise, but the old system is significantly safer for my personal career trajectory.
Yeah. And the third, ineptitude.
Ineptitude occurs when an organization tries to act, but they lack the courage to fully commit, so they compromise. They do it halfway.
The halfway fix.
Exactly. They spend millions implementing the new digital workflow, but they allow departments to keep using the old paper forms just as a backup. Half-implemented solutions generate zero systemic improvement, and worse, they breed deep organizational cynicism. 2 years later, the staff says, see, we tried TOC and it was a disaster.
So step 3 is not an engineering instruction at all. It is a severe conflict resolution challenge. You have to dismantle the psychological, financial, and structural barriers to change.
Precisely. If you fail to resolve the underlying conflict between the old rules and the new reality, the constraint will never truly be broken.
Which brings us to the absolute climax of this framework, Innovation 5, the ProConCloud method. Because if step 3 exposes that fixing constraints requires resolving intense, deep-seated human conflicts, how do we actually do that? Because standard corporate conflict resolution usually just means compromise.
Right.
Like HR demands a 4-week rigorous hiring process, operations demands a 1-week rapid process, so the VP splits the difference at 2.5 weeks, and both departments are miserable.
Compromise is the absolute enemy of optimization. Dr. Barnard makes a crucial philosophical distinction here that I consider the most vital takeaway of the entire white paper. He aggressively separates problem-solving from innovation.
How does he define the difference? Because corporate buzzwords treat those as synonyms all the time.
Problem-solving is essentially making a choice between existing suboptimal options. It inherently involves a trade-off. You accept a negative to gain a positive. But innovation, true systemic innovation, is the act of engineering a solution without trade-offs.
Without trade-offs.
Yes. It is creating a reality where you do not have to give up what you need, and you do not have to tolerate what you don't want.
So compromise is just problem-solving. Innovation is creating a third option that makes both sides whole. But how? Because traditional decision matrices don't do this. The paper lists classic tools like Benjamin Franklin's ProCon list, Jack Canfield's E plus R equals O, even Goldratt's own evaporating cloud. Why do they fall short in the real world?
They are brilliant theoretical tools, but they struggle against the gravity of human inertia. A standard ProCon list inevitably devolves into weighing 2 bad options and picking the least bad one. Goldratt's evaporating cloud is a masterpiece of formal logic, but it is highly abstract and notoriously difficult to teach to a room full of stressed-out, defensive middle managers.
So Dr. Barnard synthesized the best elements of these historical frameworks into a single, highly intuitive 5-step process called the ProConCloud. And the promise is that any team can deploy this in a single afternoon session to generate actual breakthrough innovation.
Yes.
Walk us through the mechanics of it. Step 1 is one problem.
Step 1. One problem. You must clearly and narrowly define the dark cloud hanging over the team. What is the single specific problem creating unbearable pressure right now? Is it a collapsing margin, a furious key client? But critically, you don't just define it in cold technical terms. You must define the emotional and social toll. Why does this cause me anxiety? Why does this frustrate the team?
Because, as we established with inertia, the resistance to change is primarily emotional, not just rational.
Exactly. Once the problem is anchored, you move to step 2, one conflict. Every major organizational problem creates a severe tension between two opposing actions: the intense pressure to change and the equally intense pressure for no change.
The gravitational pull of the status quo.
Right.
And here is where the pro-con element is introduced, but it's structured into 4 specific quadrants, right?
Right. You don't just list the generic pros and cons of your new idea. You map the pros of change and the cons of change, but then, crucially, you explicitly map out the pros of no change and the cons of no change.
Why is forcing people to articulate the no change quadrants so vital?
Because it reveals the hidden architecture of why smart people disagree. The young engineers pushing for the new cloud architecture are exclusively looking at the pros of change, like speed and scalability, and the cons of the old system, like crashes and tech debt. But the veteran IT managers resisting the migration are obsessively looking at the pros of the old system, that it's highly secure, we understand its quirks, and the cons of the new one, that the migration will take 6 months, the security protocols are unproven.
So both sides are 100% factually correct about the quadrants they're looking at.
Exactly, but neither side is looking at the whole board. The 4 quadrants put the entire psychological reality on a whiteboard.
Okay, the conflict is mapped. Everyone feels validated. But we still have a business to run. We have to make a decision. This leads to step 3, and this is where the framework becomes an engine for genius. Step 3 is one innovation, designated as change plus plus. What are the 2 pluses?
This is how you escape compromise. Instead of choosing a side, we construct a new reality. We start with the core change option, and we subject it to 2 rigorous design questions to attach the 2 pluses.
Question number 1.
Plus number 1 asks, what specific mechanism can we engineer and add to our change plan so we absolutely do not have to give up the unique pros of no change?
So, using the IT example,
Yeah.
How do we get the speed of the new cloud architecture, but design it so we strictly maintain the absolute security and familiarity of the old system?
Exactly. You are forcing the team to engineer a bridge that preserves the psychological safety of the status quo. Then you apply plus number 2. What specific mechanism can we add to the change plan so we absolutely do not have to suffer the unique cons of change?
How do we migrate to the new cloud without suffering the 6 months of agonizing operational downtime?
Right. When you successfully answer those 2 design constraints, you have created a change plus plus option. You have captured the massive upside of change, preserved the vital benefits of the status quo, and systematically neutralized the downside risks. Barnard points out that this methodology intentionally creates what Nassim Nicholas Taleb defines as an anti-fragile option.
Right, an anti-fragile option.
It is a strategy with massive potential upside, but tightly controlled minimal downside. It actually gets stronger when subjected to stress.
It's a complete paradigm shift.
Yeah.
You are no longer arguing across a table over 2 flawed choices. You are standing shoulder to shoulder engineering a super choice. But obviously, as soon as you present this brilliant super choice to the wider company, the skeptics are going to start taking shots at it. Which leads to step 4, one plan.
Yes. When you unveil a change, plus innovation, intelligent, experienced people will immediately respond with, yes, but the vendor won't agree to those terms. Yes, but compliance will veto it. Barnard's philosophy is that this isn't toxic resistance. It is vital intelligence. Every yes, but is a legitimate operational concern that your plan has missed.
So how do you disarm the yes buts?
You capture them and convert them into yes and.
Oh, that's brilliant.
Every voiced concern becomes a mandatory step in your implementation plan. Yes, but it might crash the server becomes yes, and therefore step 1 of our project plan is to build an isolated sandbox environment to test the load. You literally weaponize your critics' intelligence to write a bulletproof project plan. You turn their anxiety into an operational roadmap.
Which completely dissolves the antagonism. You are deputizing your biggest critics as co-architects of the solution. And then finally, we have step 5, one experiment.
Stop arguing in conference rooms and start gathering empirical data. Turn the debate into an experiment. Design a localized, safe-to-fail test with a clear start date, a highly specific measurable outcome, and strictly limited downside. If the experiment validates the change plus hypothesis, you scale it globally. If it fails, you learn exactly why it failed without tanking the quarterly earnings.
I want to cement this with the case study in the paper because the application of ProConCloud at the United Nations World Food Program is just a masterclass. It revolves around a conflict that literally every public sector and corporate manager on Earth deals with. Spend it or lose it.
It is the most universally entrenched, destructive conflict in bureaucratic history. Every government agency, every massive NGO like the UN operates on strict annual budgets. And the unwritten law of the universe is, if a department manager doesn't spend 100% of their allocated budget by December 31st, the finance committee will assume they didn't need the money, and their budget will be brutally slashed the following year.
Which incentivizes incredibly toxic, wasteful behavior. It's the December IT spending spree. Suddenly, every department realizes they desperately need new iPads, ergonomic chairs, and expensive consultants just to zero out the ledger.
It's institutionalized waste. The conflict is clear. Spend the money unnecessarily to protect your future capabilities, which is the change, versus save the money because it's the right thing to do, which is no change. The traditional compromise is just trying to hide the money in rolling accounts or making semi-useful rushed purchases. It is a pure lose-lose scenario for the organization.
So how did the UN World Food Program use the ProConCloud to shatter this conflict?
They mapped the 4 quadrants. They acknowledged the absolute reality that department managers needed the security of their future funding, the pros of no change. But they also acknowledged that the central UN desperately needed to free up liquid cash to deploy for actual unforeseen global emergency relief, the pros of change.
So they needed an innovation without trade-off.
So they engineered a change plus protocol. They named it Save It and Share It.
How did the mechanics of Save It and Share It actually work?
They fundamentally altered the incentive structure. The new organizational rule was, if a department operates efficiently and comes in under budget, they are no longer penalized. Instead, they are guaranteed the right to keep a specific percentage of those realized savings, and they can roll it over explicitly to fund their own future unfunded priority projects.
Oh, what?
The remaining percentage of the savings is returned to the central UN fund to be deployed globally for emergency famine or disaster relief.
That is beautiful. Let's look at the pluses. Plus number 1. They completely preserved the security of the department's funding capabilities. The manager actually gets more discretionary funding for their PEB projects. Plus number 2, they eliminated the penalty for efficiency. No one gets their baseline budget cut next year just because they were frugal this year.
It was a monumental success. It perfectly aligned the local self-preserving incentive of the middle manager with the global humanitarian goal of the United Nations. It unlocked massive reserves of capital for emergency relief without requiring a single dollar of additional external fundraising. It wasn't a weak compromise. It was a systemic innovation without trade-offs.
All right, let's pull the lens all the way back. We have journeyed incredibly deep today. We started with Goldratt's mandate to stand on his shoulders, and we have rigorously unpacked Dr. Barnard's 5 massive expansions designed to conquer real-world complexity.
Let's synthesize the architecture of what we've covered. Step 0. You must define your specific goal first. Are you optimizing for more, faster, better, cheaper, or simpler? Innovation 2. You deploy the multidimensional chain analysis to isolate the correct physical constraint for that goal. Are you hunting the weakest, longest, faultiest, heaviest, or most complex link?
Right. And then innovation 3. You implement TQ over OE to measure true productivity, isolating quality to ensure your metrics actively punish self-destructive local cost cutting. Innovation 4. You internalize that overcoming constraint is not an engineering task. It is a profound conflict resolution challenge against the deeply ingrained old rules.
And innovation 5. You deploy the ProConCloud methodology to resolve that human conflict, abandoning compromise to engineer anti-fragile change plus innovations.
It is a stunningly comprehensive, battle-tested toolkit. But as we close out this deep dive, I want to leave you, the listener, with 2 final highly provocative concepts from the end of the text.
Oh, these are great.
The first is a psychological reframe that is incredibly potent. When you are staring down a failing complex system and you are feeling the weight of the inertia, Dr. Barnard strongly advises abandoning the question, is this goal achievable?
Because the human brain is a threat detection machine. If you ask a room full of experts, is it achievable? Their brains will immediately generate a list of 20 highly logical reasons why it is impossible. You defeat yourself before you start.
So what's the alternative?
Instead, Barnard trains leaders to pivot to a slightly different, exponentially more powerful question. It's impossible unless.
It's impossible unless.
Yes, it's impossible to double our throughput without hiring. Unless what?
Oh.
By forcing the brain to answer the unless, you compel it to identify the specific necessary conditions that would suddenly make the impossible viable. When you pair that question with the ProConCloud, you systematically dismantle your own self-limiting beliefs.
It's a cognitive cheat code for breakthrough thinking.
Yeah.
But here's the final thought. There's a section at the very end of this white paper that reads like speculative science fiction, but it's currently being deployed in enterprise environments.
It's wild.
Dr. Barnard explores taking this entire theoretical framework, the 5 dimensions, the TQ over OE equations, the constraint algorithms, and integrating it directly into massive digital data streams, plugging it into ERP systems, global supply chain software, and digital twins.
This is the absolute frontier of operations management. Historically, the theory of constraints has been a reactive discipline. You wait for inventory to pile up on the factory floor, you visually identify the bottleneck, and then you scramble to fix it.
Right.
But by embedding this multidimensional logic into real-time transactional data and utilizing advanced simulation modeling, organizations are no longer reacting. They are predicting where constraints will mathematically emerge before they manifest in reality.
They are transitioning from constraint management to constraint prediction. We are moving from a stethoscope to an MRI. So I want you to ponder this as you close this out and head back to your day. What happens to your specific industry, to your daily workflow, when we stop reacting to bottlenecks? What does your job look like when you have a digital twin of your business that identifies the exact friction point and proposes the change plus solution 3 weeks before the crisis was scheduled to hit your desk?
It fundamentally rewrites what it means to be a leader. You evolve from being a firefighter, constantly putting out local blazes, to being an architect, designing a globally optimized system.
Remember how we started this deep dive? Talking about the comfort of that medical x-ray that cleanly shows you the broken bone.
The binary diagnosis.
Right. Well, what Dr. Barnard has engineered here isn't just fixing the x-ray machine for complex businesses. He has built a diagnostic engine that not only reveals the hidden multidimensional illness, but provides the exact conflict resolution tools you need to cure it and predicts what will break next if you ignore it.
He truly stood on the shoulders of a giant, and he is granting us the capability to see miles further into the future of our own organization.
Absolutely. So as Goldratt warned, do not treat this deep dive as dogma. Treat it as an active invitation. Take these 5 innovations, test them against the messy, chaotic reality of your own world, and see what you can build.
Challenge the old rules.
Always. Until next time, keep digging deep.